Hi, scientists. I'd like to read to you readings about surface tension and, of course, how water is everywhere. After your reading, I'd like you to complete the organizer that you have been given. Heading: Surface tension. Have you ever seen an insect walk on water? If you have, you may have wondered, how, it, how can it do that? The answer is surface tension. Water is made of tiny particles. The particles are naturally attracted to one another. At the surface, where water meets the air, the attraction between particles is very strong. The strong attraction at the surface of the water is surface tension. Insects, like water striders, can walk on water because bristles on their feet keep them from breaking through the surface tension. You can see how surface tension works. Fill a glass to the top with water. Keep adding more water a little at a time. If you are careful, you can overfill the glass. The water will form a dome above the top of the glass, but it won't spill out. Why? Surface tension. And scientists, we observed this yesterday when we dropped water on the surface of our coins. What happens when water falls through the air? Water forms drops. Drops are small volumes of water with surface all around. The skin like surface tension pulls all around the outside of the drop. The pulling results in a sphere. Next time you are in the shower, look closely at the falling water. What do you see? Without surface tension, rain falling from clouds might fall in sheets or strings. Without surface tension, water landing on a window, a car, or a leaf would spread out into a thin film. But the water doesn't make a thin film. It forms dome-shaped bits of water called beads. Why do you think water forms beads when it falls on a waterproof surface? Remember surface tension the next time you watch water striders zip across the water. Or we also talked about mosquitoes. The little insect glides over water as if they were skating on ice because of surface tension. And yes, we observed this during our investigation when we dropped water on wax paper and different surfaces. Which way does it go? Go outside during a rainstorm and look around. What happens to the rainwater? Some of it soaks down into the soil. Some of it flows across the ground, sidewalks, and paved surfaces. Water always seems to be on the move. Why is that? Let's follow a few drops of water that are on the move. Look on top of the mountain. There is still some snow high up around the peaks. Drops of melted snow flow down the sides of mountains and into brooks. Brooks join to form streams, and streams tumble over cliffs as water falls. These photographs show how water is in its different states. Streams flow into rivers. Drops of water in rivers slow down when the river is dammed, but they don't stop. When water drops pass over the dam, they flow to the ocean. When water gets to the ocean, it finally stops. Or does it? There may be more to the story of a water drop. Look again at the pictures. Follow the water drop from the mountain peak to the ocean. Which way does it go? Water always flows in the same direction. Water always moves down. Water is matter. Like all matter, water is pulled downward by gravity. That's why brooks flow from mountain peaks to forest meadows. That's why meadow streams flow into river valleys. That's why rivers flow down to the ocean. The next time it rains, watch the water flowing across the ground. Which way is it going? So I frog hopped over to our next section. Header, water everywhere. It's easy to take water for granted. Water is everywhere. It's the most common substance on our planet. Water covers more than 70% of Earth, but only 1% of all Earth's water is fresh water that people can use. Water is one of Earth's most precious natural resources. All living things need water to survive. In some areas of the world, water is scarce and more valuable than gold. Even in parts of the United States, droughts and water shortages can occur. Header: how much water do we use? Each American uses about 300 to 380 liters of water each day. So think back to our math knowledge about liters. Flushing the toilet uses between 15 and 26 liters each time, depending on the type of toilet. A bath uses about 114 liters. A shower uses between 19 and 38 liters per minute. Do you leave the water running when you brush your teeth? If so, you use from 3 to 7 liters of water each time. A dripping faucet can waste more than 3,800 liters of water each day. Header: be a water watcher. What can you do to conserve water? An easy way to conserve water is to pay attention to how much water you use each day. Here are some other tips to help you become a water watcher. Keep a pitcher of water in the refrigerator. Then you won't have to run the faucet to get really cold water. Take short showers instead of baths. Use low flow faucets and shower heads. Don't let the water run while you brush your teeth. Also, turn off running water while you soap up your hands. Don't throw facial tissues and other trash into the toilet. Use a trash can instead. This will stop clogs and cut down on the number of times you flush. If you have a fish tank, recycle the water by giving it to your plants. The fish tank water is a good plant fertilizer. There is a caption: a short shower uses less water than a bath. Fill her up, Header. Get the lowdown on these amazing measurements. Fun facts: elephants need a lot of water. They can drink from 75 to 100 liters each day. The average American drinks about 19 liters of orange juice each year. 9 out of every 10 Florida oranges are squeezed into juice. The average American eats more than 24 liters of ice cream a year. Camels are prized animals in the desert. They can go for long stretches without any water. A camel that has gone without water for a long time can drink 100 liters or more at once. Vacation aggravation. January 3rd. Dear Grandma and Grandpa, we just arrived in Sydney, Australia. Wow, did I get a big surprise. I had read that the January temperatures in some parts of Australia were usually around 28 inches. Oh, excuse me, 28 degrees. Got to get my eyes checked. I packed all my warmest winter clothes after I read that. When I got off the plane, it was unbelievably hot. I thought it was some kind of weird heat wave. Made a big mistake. Temperatures in the northern part of Australia do average 28 degrees in January. but that's 28 degrees Celsius. That's about 83 degrees Fahrenheit. It turns out that because Australia is in the southern half of the world, their summer is our winter. Mom's still pretty mad. She had to buy me a bunch of shorts and shirts to wear. She says that's the last time she'll ever let me pack my own suitcase. Love, Amy.